Good people, welcome to JJ Tech Tutoring. Here again in our second tutorial under the series of control system, right? Just a recap. Um, to our previous tutorial, we talked about control systems. I actually introduced you to control systems. If you haven't watched it, you can go and watch it. Or if what you actually want is right here, or what you're actually looking for is just open and closed loop control systems, then you're more than welcome to just watch this. But if you then want an introduction of the whole control system, then you have to start from tutorial 1. Otherwise, let us dive into it. Right? Okay. I almost forgot. I wanted to give you a recap of what is a control system. A control system manages, directs, and regulates the behavior of a process or a device, right? So it ensures the output. It ensures that the output follows the desired input, and then two main types of control systems. We then have open and closed loop control systems, which are the ones that we're going to talk about now, right? Now, let me then draw something for you here. Let me just draw the two of them, whereby we will have a controller and process. And then here, obviously, we will have an output, and then here we will have an input, right? So basically, this is a control system. This is a control system. A control system. This is a control system. Right? So this is basically an example of an open loop, right? So an open loop system is totally independent, right? So an open loop system, an input under open loop system, an input is totally independent of the output of the system, right? So this one here is totally independent of this one, right? So this one does have no business with what happens in the output, right? Whatever that happens in the output, this one doesn't have any business with it, right? For an example, when we are using that immersion water heater, right? So there are those water heaters that we used to actually have, right? Whereby there is something that was created that you go and plug it in the electricity so that it can heat up the water, whether you want to bath or whatever, right? So you will then plug that into your water in a bucket or a bowl or anything, right? So this is an input, right? So your output will be the water that is warm, the water that is hot, right? But this doesn't have a feedback, right? So it does not have a sensor in water here that will give you the feedback to say, hey, I'm hot enough now that you can use me, right? So that is why I'm saying an input is totally independent, right? It's totally independent of an output. It has no business to do with the output, because here in the electricity, this one made this ion to be very hot. Then from there, the ion then heats up the water, right? So this one will not stop until you personally remove it, right? So that is why the accuracy of open loop system depends on the experience of the user, right? So that you are using it efficiently, it depends on you, the user, right? It cannot automatically send a signal to you that I'm done. The likes of toaster, right? The likes of toaster, right? You put your bread there, right? You put your bread there, and then you set a time, right? So it has no business with whether your bread is ready or not, whether it's over ready or not, right? It can burn it, it can not even make it ready. It depends on the time, right? So it is not going to give you a signal that your bread is ready, right? Your bread is ready to be eaten. It's just gonna work until the time that is set, right? So basically, I think you then understand now. I think you understand very well the open loop. Now let's go to closed loop. Right, closed loop system. All right, so we're just gonna go and draw those diagrams again. Just gonna go and draw the diagrams again. We then included the summation because the feedback is coming back in output. Right, so we spoke controller and process. Right, we spoke about the open loop, right? And then the open loop is what I just drew here, right? So now the difference between closed loop and open loop is what? Closed loop, we have a feedback. We have a feedback. So basically, the machines that works with sensors that can automatically turn themselves off and on, that means those machines falls under closed loop, right? Because in closed loop, the output is measured continuously, right? The output is measured continuously and it is fed back to the input, right? As you can see here, it's our output, and then now it is being fed back to the input. Then the likes of example can be air conditioner. Air conditioner. With air conditioner, you can turn it on. Maybe you set it into 32 degrees, 30, 28. But the moment it realizes that the room is now too hot, it will automatically switch itself off for a while. Then from there again, it will switch itself on. That means it is then sending the feedback back to the input, right? Because here we usually have the desired output, right? We then tell it that we want the room to warm, right? We want it to warm up the room, right? Then once the room is too warm or is too hot, then there will be a feedback that is sent back to the input that, hey, I'm very warm. Hey, the room is now warm. You can turn it off a little, right? So that is why input can depend on the output. If the output has already met or has already passed what we are supposed to get, right? That's it. So the likes of geyser as well, it knows when the water is too hot, too cold, then it can interchange, right? So closed loop, as I've said, are those machines that works with sensors, right? So for an example, if we're using air conditioner, the moment the temperature become what is actually requested, then automatically it will turn off and then turn on when it is needed, right? That's it. Right now, we can then talk about, we can then try to compare them and their disadvantages, advantages, and all, right? So with open loop, it is very simple in construction, right? So it is easy to design. It is very easy to design and it is very economical. It's not that expensive. But when we talk about closed loop, closed loop is expensive, but it is reliable. And open loop is not reliable. All right. Then what is it that distinguishes the key component that actually distinguish them or that set them apart is feedback. The other one does not have a feedback, the other one has the feedback, right? So the reason why open loop is not as efficient as closed loop is because open loop does not have feedback and then closed loop does have a feedback, right? So basically that is the difference between open loop and closed loop. So this is what you need to know in order to excel in controls and systems and in knowing the difference between open loop and closed loop. Then don't forget to subscribe.